Hello friends, welcome back to my channel Siddhanath Nishanda. In last lecture, we started a new topic gas turbine and jet propulsion. Please go through the previous video. Today we cover the remaining part of the constant pressure open cycle gas turbine and the closed cycle gas turbine. In previous lecture, we discussed the classifications on the basis it works on operation. I just revise in short open cycle, closed cycle, on which thermodynamic cycle it works, maybe Breton, Atkinson, and Ericsson. The constant pressure open cycle gas turbine. It consists of three main components: compressor, combustion chamber, and the gas turbine. Okay, if we see, there is two applications where we had told in the wings of the aeroplanes, that is the turboprop or turboprop engines. Also utilized for the stationary grid electric grids for generating electricity. If we draw the open cycle gas turbine PVTS diagram, number of students made mistake that they join the line 4 to 1 because the cycle is open. Exhaust from the turbine we can't use again and again. Okay, if we see there is 1 to 2, there is isentropic compression which is carried out, maybe axial flow compressor or maybe centrifugal compressor. I show in animation there is axial flow compressor. If you observe here, the number of blades are mounted on a shaft. Some blades alternately stationary and some blades are rotating continuously. Okay, mostly the stationary blades are placed in the casing and the rotating blades are mounted on the shaft. That is axial flow compressor. The 1 to 2 is isentropic compression. 2 to 3, why it is called as a constant pressure cycle? There is a fuel injected in the CC. I told that out of 100% air, if you assume, out of the 100%, 25% air is only utilized for the combustion purpose, and that is the that combustion is carried out in the inner space. The CC or combustion chamber is like a inner space and the outer space. In inner space, the combustion is carried out. They only utilize 25% air, that is called as a primary air, and the remaining 75% air is called as a secondary air to utilize to cool the combustion chamber. If you use 100% air, the temperature goes to the around 2000 degrees Celsius. Okay, because of some material considerations, some temperature limits, material limits. Okay, so only we utilize 25% air and the temperature is around 800 degrees Celsius. We maintain the temperature. After that, 800 degrees Celsius is possible because of the second air which cools the CC. Okay, that addition of heat, the fuel injected at constant pressure. If we see here, that natural gas and oil is directly comes in contact with the compressed air is very important as compared to the closed cycle. If we further discuss in coming slides, there is the fuel and that compressed air comes in directly contact. So our limitation is that if you use the air or you use any gas have proper properties. Okay, because the further it affects on the turbine blades or the components. So be careful which gas or which air is properly filtered, having proper chemical compositions. Now see there's one, now see one animation here. Okay, on wings that are, we see in the first slide. Now we see how it works in case of aeroplanes. We see this is a very fast process. In further video we slow what actually happened, the step by step. Okay, this whole section is now divided in three parts. I told that compressor, combustion chamber, turbine, and nozzle is there. This is one important part. It wings and works on a principle of the Newton's third law. There is every action there is equal and opposite reaction. When axial flow compressor starts, it sucks the atmospheric air. Okay, now that air flows or the squeeze or flows axially over the compressor. The blades of the compressor, if we see in the video, The carbon fiber blades are there. Now squeezing is there. I told there is the rotating blades and the stationary blades. Initially air flows over the low pressure compressor. Now that air now flows over the high pressure compressor. Is similar to the two-stage compressor. Initially the volume of air is large to accommodate that air. So initially compressor having large volume to handle the further after compression, that air is now go to that high pressure compressor. Now that high pressure high temperature compressor now go through that combustion chamber where the fuel is injected, the particle of kerosene we see. Okay, now that further this combustible product forms. If we see there's a chemical composition shows in the animated, there's particles, high pressure high temperature, that rare particles and the droplets of the kerosene. There's a random movement of that fuel droplets and the compressor air. Now they are ready to expand in the turbine. Okay, now they flows over the turbines. We get the mechanical power. That's some of the mechanical power utilized to run the compressor again. Okay, there's a gas turbines. After that, that exhaustible gas then again expand in the nozzle, which propel the plane. Okay, further we discuss in the coming videos how it works. This is actually, I have this video mentioned here because of some applications we know actually how it works. Okay, now we see the closed cycle gas turbine. The change is that after combustible extraordinary gases, suppose see the 1 to 2 is the compression, the addition of it is carried at constant pressure, and the 3 to 4 is the process carried out in turbine. Okay, the 3 to 4 this is isentropic expansion, and the 1 to 2 the isentropic compressor. The addition of heat and the rejection of heat is carried out or takes place at the constant pressure. So it is work on principle of Breton or Joule cycle. The change is that, okay, if we see that combustible gases exist from the turbine is cool here. Okay, but very important change is that in CC here, the combustion chamber. Okay, 1 to 2, the compress the air up to 40 bar. The compression is very high as compared to the open cycle gas turbine, because if I told that in open cycle gas turbine there is a direct mixing of that compressed air and fuel injected, but in case of closed cycle gas turbine, okay, there is an indirect combustion. I again repeat, if you compress the air up to 40 bar and that compressed air, that addition of heat is carried out externally over the CC. So it is main advantage that in closed cycle gas turbine any fuel we can use, maybe solid fuel, liquid fuel, low cost fuel, because there is no indirect contact with that compressed air. But in case of open cycle we use proper fuel, because some material considerations it affects on the life of the blades, turbines or that compartment. Okay, there is no problem in case of closed cycle gas turbine because the compressor is not then directly come in contact with the fuels. So after that air expands, after addition of heat, that air now going to expand in the turbine. This is a very important term. Okay, as compared to the open cycle and closed cycle gas turbine. Now we see the advantages of closed cycle gas turbine. The major advantage of closed cycle is the use of high pressure throughout the cycle. Okay, I told up to 40 bar, which results in a reduced size as compared to the open cycle. The closed cycle has a plant capacity or the plant size is small. Combustion is externally. Any type of fuel can be used. That is less costly fuel can be used. The working medium remains free from pollution of products of combustion, and hence the interior of the plant remains clean. Is very important advantage over the open cycle gas turbine. The damage of the turbine blades due to erosion, corrosion is thus reduced. Another advantage is improved part load efficiency. working cycle is closed, there is no loss of working medium, low maintenance cost, high reliability, long life, greater output, and the lesser fluid friction. Okay, some there is disadvantages also. Large amount of cooling medium is required for a pre-cooler. Okay, because of that, after expansion up, there is the high pressure, high temperature, or that air is need to cool. So we need more amount of cooling medium. System is a complex. Wet to power ratio is high. Due to heat transfer coefficient, a very large air heater is to be used. There's some advantage, some disadvantage. Okay. Through this video, I cover open cycle gas turbine and closed cycle gas turbine. Thank you.